Hey, let's talk about capturing user requirements. We're building software for users, so we want to just briefly talk about capturing user requirements. Typically, it's not something you will do a lot as a software developer. Your product owner or your product manager should be doing that for you on a larger team, but you should understand the process a little bit so that you can raise up an issue if you don't think that the user requirements are actually good enough for you to start developing against. Um, there is no silver bullet. Writing software is a complicated and arduous task. In 1986, Fred Brooks said that there was no silver bullet. He's got this sentence here. The explanation of that sentence is basically it's really complicated. There are advances in technology and management limitations, but none of them are going to make things 10 times better. Because of that, we need to continue to struggle and in terms of productivity, reliability, and simplicity. Uh, and we can improve these by looking at better tools, improved processes, skilled teams, and a deeper understanding of the challenges involved. And we should really have realistic expectations. And this is going to be important for you as you work on your project over this semester. We are talking about software engineering processes. And so what we want to do today is we want to talk a little bit about how do we understand what software we're supposed to build, how do we organize and develop our development activities, how do we plan a software project, and how do we build an effective team. In this particular video today, we're talking about how do we understand what software we are supposed to build. We're going to talk about the overall purposes of requirement analysis, i.e., to understand what we want to build. We're going to talk we're going to talk about the three major dimensions of risk in requirements analysis, ways that you can look at requirements analysis and decide whether it's good or not. We will talk about functional and non-functional requirements, and finally we'll talk about a user story, and we'll give a couple of examples. Uh, the top reasons why startups fail. Look at that first one, no market needed. So they built something that nobody wanted. 42% of the startups that fail have built something that nobody wanted. So they didn't actually go and talk to their customers. They thought that they understood the customers. They didn't do their research properly, and nobody wanted to buy it. So along comes a guy and says, I want to build something that's attached to the branch of a tree that I can swing from. And this is kind of what the customer had in their mind, but they talked to a person who was used to building things with pieces of wood. So this is what the customer explained. It didn't say tire, he just said, I wanted some ropes that attach to things that I can sit on. And then the project manager kind of looked at it and said, okay, you have two ropes attached to a tree with something to sit on, unable to swing. Then the analyst came along and said, oh, we've got to have to swing that, so we're going to add this branch here and this branch here. The programmer came along and said, we need two pieces of string attached to a tree with something to sit on, and boom, there you go. That's what we got. So this illustrates the complexity of clearly communicating the features that the customer wants, that the project leader wants, that the analyst wants, that the programmer wants. These are all different people that need to learn how to communicate with each other. So the requirements analysis and planning and design and implementation, today we're talking about requirements analysis. So in requirements analysis, there's three dimensions of risk. The first one is understanding. Do the users actually know what they want? Do the users know what we don't know? Do we know who our users are? As you saw, 42% of startup companies didn't know who their users were. In fact, their users didn't exist. Um, the problems of scope. Um, are you starting to build a replacement for Windows with three people? No, that's not going to work. Have you thought carefully about the non-functional quality attributes? So you have an idea of how to satisfy the user, but you don't have any idea whatsoever about what technologies you're going to build underneath that. Is the user going to change their mind? You know, the user's going to come back and look at your MVP and go, oh, that's not what we wanted. So there are these three dimensions of risk, which are understanding, scope, and variability. So what do we do? We go out and we ask, first of all, the users can just tell us what they want. The client determines the problem, and then they write up the requirements, and then they give us a document and we develop it. The second one is we go and talk to the customers. We go and interview them, but what do they want to do? Why do you want to do this? In fact, if you can embed your client into your design team. Uh, Sometimes that's easier done. It's easier to do that. When I worked at Relic Entertainment, a video games company, and we were building tools for our animators. We could go and sit next to the animators to see how they were doing their work, and then we could see how they were doing. So they basically would come and sit in on our sprint retrospectives and see what we were doing. Sometimes you don't want the clients to be inside your team. In that case, your product manager is the person that's supposed to be representing the client and your document. So you want to have the documents that allow you to go back to the client and say, this is what we're thinking of building. Do you agree with that? Yes or no. Once you've done all of this stuff, you have credibility and authority on your team. As I said before, write the documentation. Don't spend too much time writing the documents so they're super formal. Make them as formal as you need for your client. Um, the documentation should capture all of the user stories, which we will come to in a second, and also the non-functional stories, which are all of the underlying things like response time, privacy, security, usability. All of these things need to be done. And also even kind of more long-term engineering. How testable is your code? How maintainable is it? Did you write it in a language that's just horrible to maintain in? Did you write it in a language that only one person on your team knows and they just quit and left? You can write your formal specifications out in these kind of formats here. You don't necessarily need to do so. Write them as formal as required for communication with your client. User stories are a great way of starting to understand what you're building for the user. A user story is a description of an experience that the user has with your software, and it has the format as a programmer. I can compile my code so that my program will run. That would be a user story for my IDE, or not necessarily for my IDE. If, like in 5001, my first assignment is to compile my programmer from the command line, then I have a user story. As a user, as a beginning programmer in a line, I can run GCC to generate an executable so that I can run my program. So the conditions of satisfaction are I expect behavior and side effects. Um, the user stories should be independent, so each user story should have like an independent um, thing that you're building. It should be small and testable. That means you can kind of estimate how long it's going to take you to build. It should add value to your product, and it should be negotiable, such that the client could say, actually, I don't want that one, or the priority of that one is going to be lower. So here's a user story example. As a computer user, I want to back up my entire hard drive so that my files are safe. Now, that's a user story. Now, remember we have role, action, and impact. So I can change the role, and I can say, as a typical computer user, I want to specify folders for backup so that my most important files are safe. Notice that I've changed the role, and I changed slightly what I want to do. And then I can change the role even more. As a power user, I want to specify subfolders and file types not to back up. So each one of these user stories is independent. It's negotiable. We could go back and say, well, we're actually not going to implement the power user ability to specify subfolders until later on in the whole product roadmap. So for this particular implementation, we're not going to do that. One way to test your user story to see if you've added too much to it is, can you write it on a 3x5 card in a reasonable size font? Don't write it in like a very tiny font. There's lots of detail that you can't put on it. Where are the backups saved? What do you do if the backup system is unavailable? What if the backup system is full? Da 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 da. So the condition, and so then you have your, but this is a good guide. If you can't write your user story on a 3x5 card, it's probably that your user story is too complex. The conditions of satisfaction. As a typical computer user, I want to specify folders to back up so that my most important files are safe. So now let's go and dig into my conditions of satisfaction. These are going to add some things about what happens. So if the network and the remote backup are available and I'm not over my storage quota, it should be successful. It should just work. After running, everything should be stored in the cloud system. Perfect. Those two are the happy path conditions of satisfaction. Then what if the backup is not failed? For whatever reason, I should get a message that says, hey, your backup didn't work, proceed with care. So we have this one condition: after successfully running an updated copy of each of the files that I have requested to be backed up are stored in a redundant cloud system. Is this a guarantee of success? Well, it is, but there are some nuances to it. Like, what if your transfer feed is really slow and it's going to take you 4 hours to back up files? That's probably not satisfactory if the number of files that you're changing is 3 or 4. Did you use a whole bunch of temporary disk space? How long did you actually have to spend with support to set up the software usability? So you're looking at performance, usability, and security aspects of the implementation. Now, you have a project and you have a set of user stories. That's your scope. You have the amount of time that your team is going to be working on it. That's your duration. You're going to have the quality at which you deliver the code. That's your quality. And you've got the salaries of the people that you have to pay for the duration to build the scope. And that's your cost. So typically cost is the most constraint. There's the budget is fixed. That would specify, how many person months you can build on this project. And then the other ones are negotiable. If you find yourself in a situation where the project cost is not bound, then you're in a very unique position, but very rarely will you find yourself in that situation. So requirements analysis, we have this so that we actually know what we're building. We have talked about the 3 major dimensions of risk in requirements analysis. We've talked about functional and non-functional requirements. They're coupled together. Functional is what the user is expecting, and non-functional is what we as engineers look at and go, oh, okay, this is how it should go. And then we've also talked about a user story with examples also associated with it, these non-functional components as well. Thank you.